Hi there. We look today at reading the second derivative graphs, and so I've selected here the top graph from your notes. It has 5 questions that correspond to that graph. If you would like to, you're more than welcome to download my notes from my website. I have uploaded them there with answers so that you can follow along with this video if you'd like. Okay, so with this top graph, we are first looking at what graph it is. This is a second derivative graph, which we know because of the nature of the notes, but it is a practice you want to get into. You will get different graphs, f prime, f double prime, and so you do want to make sure you take a moment right at the beginning and make note of what your graph is of. If this is of f double prime, because that's going to change how I address my questions potentially. Okay, so this is f double prime, and my first question is I'm asked, where is f concave up? And if this were an f graph, that would be easy to answer. F concave up like a cup, and I'd be looking for my cups. But this is not an f graph. This is an f double prime graph. And so I need to translate my directions, f concave up, into f double prime. Okay. So f is concave up when f double prime is positive, which means to address this question, we're going to be looking at where's this graph above the x-axis. This graph is above the x-axis. This graph is positive from negative infinity to 0.5, and also from 2 to 3, and also from 5 to infinity. Okay. So definition of f concave up means that f double prime is positive. So then we're on to number 2. Number 2 asks us, where does f have a point of inflection? And so for this one, it's helpful to kind of address what the definition of a point of inflection is. And so I'm going to write this up here. Point of inflection, just as a reminder, is where our function changes concavity. It was concave up and becomes concave down, or vice versa. That's the definition of point of inflection. And so then using that definition in conjunction with our concavity definitions, definition of concave up and of concave down, we can then address how to find a point of inflection on an f prime graph and on an f double prime graph. So pretend for a second this were an f prime graph. What would we be looking for in order to find points of inflection? Well, when f is concave up, f prime is increasing. And when f is concave down, f prime is decreasing, definition of concavity. And so that's what you're going to be looking for on an f prime graph. Where do I switch from increasing to decreasing, or decreasing to increasing? And finally, on an f double prime graph, which is what we're working with today, when f is concave up, f prime's increasing, f double prime is positive. F concave down, f prime decreasing, f double prime is negative. And so that's what you're going to be looking for on an f double prime graph. So for number 2, when we're asked, where does f have a point of inflection? Well, I'm not looking at f, so I can't look for that change. I'm not looking at f prime, so I can't look for that change. I'm looking at f double prime. And so I have to look for this change, positive to negative or negative to positive, which occurs here. We went from positive to negative, here, negative to positive, here, positive to negative, and here, negative to positive. And so my 4 points of inflection are 0.5, 2, 3, and 5. Okay. Number 3, we're asked, where is f prime decreasing? Well, f prime, in terms of f double prime, f prime decreasing means f double prime is negative. Right? F prime decreasing means f double prime is negative. And so I'm going to be looking to answer this question, where is my f double prime below the x-axis? Which is here from 0.5 to 2, and here from 3 to 5. Okay, number 4, we are asked, where is f concave down? Again, I'm not looking at an f graph, so I can't look for the frown. Instead, I need to translate this direction into terms of f double prime, because that's what graph I've got. F concave down means f double prime is less than 0. And so essentially, number 4 is kind of the same question as number 3. It's just phrased differently, right? Definition of f concave down, which is number 4, is that f prime is decreasing, which means f double prime is negative for both of these because they're kind of synonymous. They mean the same thing. They're the definition of each other. Okay, so where is f concave down? It's where f double prime is negative, which again is 0.5 to 2 and 3 to 5. And finally, where is f prime increasing? F prime increasing is when f double prime is positive. And so this is the same question as number 1. Number 1, we're asked where is f concave up? Definition of f concave up is that f prime is increasing and that f double prime is positive. And so where is f prime increasing? Where f double prime is positive above the x-axis, which is negative infinity to 0.5 and 2 to 3 and 5 to infinity. And that's a second derivative graph.